Okay, so now let's go and get on to example number 2. And example number 2, we're just looking into actually evaluating the operations. And so we're not going to be worried about the domain. We're just going to look at like what is the value of our new function for a given value. So in this first example here, we are just looking at the product of f times h of 4. Now we can do this a couple different ways. We could multiply our functions first and then evaluate them by 4, but you know that could kind of get a little bit cumbersome. You know, we could multiply these and then plug in 4, which is fine. But if you remember, f times h might not be the easiest, to multiply. So another way to kind of look at this is really just saying we could take this as f of 4 times, h of 4. So now exactly, if I just want to evaluate for like f of 4, I'm going to take the f of x function, which was, x minus 3, and then plug in 4 in for the x. So f of 4 can be related as 4. Geez, why do you do that? No, stop doing that. That'd be 4 minus 3. And then that's my f function. And then times my h function, h of 4, is going to be 3 times the square root of 4. So now, in this example, now all I'm going to do is simply simplify each of these and then multiply them. So 4 minus 3 is 1. And then 3 times the square root of 4, square root of 4 is 2. 3 times 2 is going to be 6. So then I'm basically just doing 1 times 6, which is going to equal 6. And I'll just put, the function is equal to that value. Here I have g divided by j. So again, in kind of another fun one, we could, if we were going to be dividing, we'd have to be, flipping and doing all this stuff. So I'm just going to take the g of x function, and plug in -1. So that's going to be -1 squared minus 4 times -1 plus 3. And I am going to divide that by my g, or j of x function, which is 2 divided by 2 times -1. And that was what? Plus 1. Okay, so now go ahead and simplifying this here. -1 squared is -1 times -1, which is a positive 1. -4 times -1 is a positive 4. Plus 3 divided by 2. Divided by 2 times -1 is -2, plus 1 is -2, plus 1 is -1. Is that the same one that I got? Did I do that one? I switched up those. No, I thought I switched up those answers though. I'm sorry, I'm just looking at my, I didn't work it out. Okay. So in this one, 2 divided by -1 just reduces down to a -2. So I'm going to do my work to the right, which I don't like doing. 1 plus 4 is 5, plus 3 is 8, divided by -2. 8 divided by -2 is just going to equal -4. So now let's do g plus f of 2. So now I'm adding my g of x function plus my f of x function. So again, g is going to be, let's see, that's going to be 2 squared minus 4 times 2 plus 3. And then add that to my f of x function, which would be, let's put that in brackets. You could use parentheses, but I'll use brackets. And then putting 2 in for the f of x function, which would be 2 minus 3. All right, so now let's simplify using a little order of operations. Let's simplify inside this bracket first. So 2 squared is going to be 4. -4 times 2 is -8, plus 3. Plus 2 minus 3 is going to equal -1. And I can further simplify. 4 minus 8 is -4, plus 3 is -4 plus 3 is going to be a -1. Plus a -1. You can remove the brackets now. -1 plus -1 is now a -2. And then the last one here, I have h minus j. So my h of x function again was 3 times the square root of 1. And I'll put that in brackets. And then I'm going to minus that from my j, which was 2 over 2 times 1 plus 1. So square root of 1 is 1, which becomes 3. Sorry, I should use equal signs there. 3 minus, let's say 2 times 1 is 2, plus 1 is 3, so that's going to be minus, 2 over 3. So again, now we have some fraction operations, just a little practice here. So remember, if we're going to combine fractions, in this case subtract, we want to make sure we get common denominators. So the common denominator of 3 and 1 is going to be 3. So I'll multiply this by 3 over 3 since the other fraction already has a denominator of 3. Therefore, I get 9/3 minus 2/3. And 9/3 minus 2/3 is going to give me 7/3. So there you go, ladies and gentlemen. That is how you evaluate two functions. Now let's go ahead and move on to the next example.